My name is Alexia Udol, and today I'm going to present to you Lab 3, Magnetic Field of a Bar Magnet from Physics 2212. The purpose of this lab was to measure the distance dependence of a magnetic field due to a bar magnet. After obtaining these measurements, we will compare them to the values obtained using the Biot-Savart law. The physics principles present in this lab are the Biot-Savart laws and distance dependence. This is a preview of my results in which n was calculated to be this number here, the net magnetic field was calculated to be this number here, and finally, the magnetic dipole moment was calculated to be this number here, in which certain calculations had to be made, which will be further on explained. These are the different formulas that were used in this lab, including the Biot-Savart on-axis law and the Biot-Savart off-axis law. Also, we have here the distance dependence equation and the linear distance dependence equation. Here we have different values. This was obtained with all of the experimental calculations. And in order to solve for mu, we had to equate the distance dependence law with the Biot-Savart on-axis magnetic field law, in which we were able to have mu all by itself, in which we were able to calculate finally the magnetic dipole moment. In this lab, we had two parts to its experiment, in which the system was always the magnet and the surroundings Earth. For the first part of the experiment, we had to measure various distances with given magnetic field x components on axis. With the linearization of the linear dependence, we are able to obtain this graph with the following equation, as you can see here, and these are the values that were obtained using the on-axis part of the experiment. For the second part of the experiment, the magnetic field 45 degrees off-axis had to be calculated. And for both parts of the experiment, the magnetometer had to be aligned with the magnetic north, for there not to be interference from Earth's magnetic field. Here you can see my results for the on-axis part of the experiment and its corresponding graph, which gave me the linear dependence value. And also here at the bottom, you can see the results obtained by measuring the magnetic field off-axis, in which I was able to get this net magnetic field, as shown in the preview of my results. Here is one of the portions of my GlowScript code, in which I included my calculated magnetic dipole moment here at the top, as you can see here, and I defined an equation to calculate the magnetic field. Furthermore, here I created the arrows that represented various magnetic fields on axis and on the perp axis. Finally, here at the bottom, we can see that I represented for the second part of the lab, in which we measured the magnetic field at 45 degrees at distance d. Here are the results of the computational model, and I also included the experimental results, in which you can see that the net magnetic field 45 degrees off axis of the computational model is way smaller than the one obtained throughout the experiment. This could be due to the fact of miscalculations of distances during the experiment. These are two observations that were made in this lab. When the magnetometer is far away from the magnet, it measures the near zero magnetic field in the x direction. And also we have this observation, which is as the magnetometer moves closer to the magnet, the measured x component of the magnetic field increases. Finally, for the what if portion of this lab, what if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? We would be taking into account Earth's magnetic field, making our results change and be inaccurate, since we would be taking into account an extra magnetic field that would be disrupting our results of the magnetic fields created by the bar magnets. Finally, what if you were to stick two identical magnets together end to end and run the experiment again, how would you expect your measurements to differ? The measurements would most likely increase, since we're taking into account both of the magnetic fields of these two bar magnets. The results would not be inaccurate, they would just increase, since we are adding one magnetic field to the one that we already have in our experiment. Thank you.